Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 31 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your gear, but those of you who don't, look down in the description. There is a link over to Amazon. You can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what we're going to do is I'm going to be showing you my solution to the homework assignment that I gave you in lesson number 30. And what that homework assignment was to go out and use what we learned about connecting our Raspberry Pi Pico W to the internet and being able to download JSON files, live data, and create some useful little widget, some useful little device. And what I had suggested would be a good topic for that project would be to create a sensorless weather station where you go out and grab real-time live weather data from the internet and then display that using the Raspberry Pi Pico W. All right, so what I will do is I will show you my solution to that today, and we will create our very own dandy sensorless remote weather station. Sound pretty neat? Hope it does. And so let me get out of your way. I have a sip of coffee. And let me switch over. At this point, we are still just working with a bare Raspberry Pi Pico W. We haven't hooked any displays or any other cool items up to it because we're still kind of focusing on how to find the data, grab the data, and parse the data, that sort of stuff. And then we will be moving forward to next steps next week, okay? But for now, we're just using the bare Raspberry Pi Pico W. All right, let's jump over here. And let's go ahead and let's go ahead and fire up Thonny. I'm going to make sure that I am connected to the Raspberry Pi Pico W. There it is. And now let's get ready to start coding. But I guess the first thing we should do is where are we going to get our weather data? Well, there is a really neat open source source of weather data. And it is at the site, openweathermap.org, okay? And that is where we are going to get our data. But if we're going to get our data, we're going to have to get an API key. That's a little encryption key that allows our Raspberry Pi Pico W to connect to the data. Now, the good news is it's free. The good news is to get the free service, you do not have to provide a credit card. And the other good news is that you do have to sign up with your email address. But the good news is I did this. I didn't get any junk email from them. So it's like small price you pay. You've got to create an account, get your API key, free. And it seems to be that they don't annoy you. and then you can move forward. So you want to come here and what you want to do is you want to come up here to API and you're going to click on that. Seems like a little bit of a delay here. Okay, here it is. And it says Weather API, and then it says, please sign up. Okay, because you're going to click on sign up. You're going to give them your email address, and you're going to create a password. And then with that, you'll probably get like a confirmation email or something like that. You go through the thing, you know the drill. All right, and then you log in. Okay, now once you log in, a couple of things is you're going to need to get your API key. Well, you come up here where it has your username and then you say my API key. And when you do that, man, my internet connection is slow today. I don't know why. But we will persevere. When you click on that, you come over here and then it will show you your API key. Now I just revealed to the whole world my API key, but before this video lesson is posted, I'm going to come over and I am going to deactivate it. So by the time this video shows, mine's not going to work. So you do have to set up your own account. You have to come and get your own API key there. Good? Very good. All right, now we are ready to come over here and start coding. So we're going to have to connect to our local area network, our Wi-Fi. So we're going to need to import network, just like last week. We're going to need to import time, just like last week. We are going to need to import micro, that's U request. You see the U looks like a mu, which is the Greek symbol for micro. So U request as in micro request as in, micro Python request, if that makes sense. Now we need to create our Wi-Fi object. I'm going to call it WLAN. I'm going to create that object. It is going to be network.wlan like that. And then we're going to go network like that .sta_if. That will create our Wi-Fi object. Now I want to say WLAN.active, and I'm going to set that to true. So I'm going to make that connection active. Now I need to go in and connect. I need to actually connect to my router. So that will be WLAN.connecta. And then you would do something like Wi-Fi name, and you put it inside of quotes. I don't know what your Wi-Fi name is, but whatever it is, you put it here. Okay, so if it's like linksys1234, you put linksys1234. However it shows up on, when you're looking for Wi-Fi, you put that exactly in there, and then you put your password, which might be, you might have like PookiePoo12, whatever your password is, you put it there. All right. Now, of course, those are not my passwords. I have put my passwords in a secrets file, so I'm going to import secrets. You don't do this part unless you have a secrets file. Okay. You do it the way I showed you down there. All right. But now I have the secrets file, so I will do secrets.ssid. That's my Wi-Fi name. And then secrets.password like that. I think that looks good. So I've got that. Now I should actually wait for it to connect. It might take a second. It might take 10 seconds. So how long do I delay? Well, I delay as long as it takes, and I do that by using while. WLAN dot is connected, while is connected equal. What is this nonsense? Equal. What is this? Oh, okay. There, I'll get it this time. Equal, false. That means if is connected is false, it's not connected. So as long as that's the case, we're going to just wait. So I'm going to say print connecting ... All right. And so it'll print this message as long as it's not connected. Once it's connected, we will drop out of that while loop and we will say print congratulations, you have connected, like that. Okay. Close the string, close the print. All right, now we should be connected. Let's just run this to make sure we haven't made a silly mistake. Silly mistake in 4. What is wrong with that? That looks line 4. It's line 4. Import. I should have seen that. Let's try it again. Okay, congratulations, you have connected. So we are able to connect to Wi-Fi. Now what we want to do is we want to go out and we want to get that weather data. Okay, we want to get that weather data. And so what I'm going to do is I'm going to create a data object that I'm going to call weather. And that's going to be equal to the U request, that library. And then that library is going to call the get method. And now I have to show you where the data file is. It is at HTTPS. And I'm going to put this high to make sure that it doesn't run into my head. Okay, because this is going to be a little bit long. But where is it? ://API.OpenWeatherMap.org. Okay, then you got to go to data, and then you got to go to 2.5 like that. Take your time. Be careful. You got to get this right. And then what do you want? You want weather. Okay. And then I'm going to show you there's several different ways you can specify where you want it. Okay, the weather for like your location. But after weather, you put a question mark. And then after the question mark, if you want to just do like city, you can put like, I'm going to put like Q. All right. And then I am going to put my city is equal to Jinja. All right. And it recognizes an amazing number of cities throughout the world. So I'm going to put Jinja, and then I am going to put comma, Uganda, and then I am going to go and then I am going to put my app ID is equal to, now we need to go get that API key. And if you followed along, you should have an API key now. And so I'm going to get mine. This will not be active by the time this video drops. And so I'm going to put it like that. No quotes around this. You just got to put that crazy number in. All right. And now I want to use imperial units, right? I want like miles and miles per hour and something like that. And so I'm going to say and I'm going to say units equal imperial like that. And now I'm going to close that quote. All right. And now I'm going to close the call. And then I'm going to tell it that it's a JSON open close. All right. So make sure you got this. You close the string, you close the call, and then you tell it that it's a .json and then an open close. Make sure that you get that right. Okay, now I'm just going to say print weather like that. Okay. And let's see, it says that, it doesn't like that syntax error in the call. Okay, let's see what we did wrong here. So I've got to look carefully because this is kind of long, isn't it? This is kind of long. So let's make sure we closed, we said units equal imperial, close that .json open close. That looks good. And I have units, and then I have app ID, and my app ID is equal to a 0, and it ends with a 3F. So I got the whole thing in an and. Uganda, app ID, that looks good. And this is sure looking good so far. So I have the question mark, the Q is equal to Jinja, Uganda. GATA. We don't want the GATA. We want the data. So let's try that. That was painful for you guys to watch me do that, wasn't it? Okay, look at that. I got a bunch of data. So that's what I care about. I got a bunch of data. Perhaps maybe the easiest way for you to do it, if we come back to the website, would be we're going to come over here and we're going to go to pricing. Okay. Man, my connection is so slow today. Okay, we're on connection, and then, or we're on pricing. Okay, so I come to pricing, and then it has these subscription plans, and you come down here under free. And what we are doing right now is we're doing the current weather. So you click there, and this is all the documentation on this particular call. So there's a lot of great things here, but you can come down to built-in geocoding. Do you see over my shoulder there, built-in geocoding? And then you can see that you can do a Q equals city. Maybe just the city name would get you there. Okay, or you could do a city and a country code, or you could do a city, a name, a city name, state, country code. Okay, those are different ways to do it, but perhaps the easiest way would be to do it here using zip code, okay? And with that, you could just come in and say zip, and then your country code, which would be like USA or Canada or whatever the abbreviation is. And here, what you can see is it actually just did it just with, just with the zip code and then comma, and then I guess US for USA. And so that should be able to get you there. So if it's not one of those, just come to this thing and it shows you all the different ways you can do it. I think I've given you enough information here that just about anybody out there should be able to get connected at this point. And let me just see, like I'm going to just comment that out and do it with lat lon there. Okay. And then you come up and you get the same result doing lat lon. And it's just, I'm going to go back to the city nation way because that is kind of easy for me. All right, so we print weather. Okay, so we have printed weather. And now you can see we've got really, I think I'm going to come up here where we can see this data a little bit more. You can see that we have just a big, huge amount of data here. And so now, as we did last week, we got to start busting up this JSON file and we got to start peeling back the layers of the onion. Now, we could go in at that site we were just at and we could read all the documentation. I just can't do things that way. I like to look at the data structure and just kind of start figuring it out. I learn by kind of breaking into it just by looking at the data structure. So when we do that, one thing that we see is we see time zone and we've got this ridiculous number. So that means absolutely nothing. I have no idea. Maybe after a little while we can figure out exactly what that is. But let's just see if we could print it. So I'm just going to say, can I get to that? And so what we notice about the data structure is we start with a dictionary and then we have a key index and a key index, and then we have a value, and then we have a key index, and then we have a value. So here we have a key index and a number, and then in the dictionary we have a key index, and then that ties to another dictionary, and inside of that dictionary can be arrays. So you can see this is really nested, but we're going to go through and kind of break into it. But let's just see if it works like we say. I'm going to just say print, even though I don't know what it means. I'm going to print weather, and then I'm going to bust down into that time zone. Just like that. Close it, close the square bracket, close the parenthesis, and now I should print out that number, just saying that I can get to it even though I don't know what it is. And we are waiting, and ooh, what did that? Oh, time zone will work better like that. All right, let's run that. Okay, congratulations. All right, and there's that number there. So we're getting into the data. We don't know what it means, but we'll figure this stuff out later. Now, the thing that I find interesting is what I would like to kind of know is what is the current time? Like we just went out and got the data, but what time is it right now in Jinja, Uganda? Can we get that from the report? What time is it right now in Jinja, Uganda? Well, what I see is this DT makes me think maybe that's date time. Maybe DT is date time. So let's go down and let's see if we can get this number out. Now, this is a ridiculous number, but let's just see if we can get it. So what I'm going to do here is I am going to say print weather. Okay, now what we have to ask ourselves as we're breaking this apart is what layer of the onion is this at? Okay, what layer of the onion is this at? Well, let me get all the way out of the way here so you can see this. Okay, we'll go to Munchkin mode. What I can see is I'm looking to get this DT value. So what I'm going to do is I'm just going to look over here and I'm going to say I see a close of a dictionary, and then I see an open of a dictionary. And so this is closing that. Then the only other thing I have is a close of the whole dictionary. And so what that's telling me is this has to be at the outermost layer of the onion. And so I don't have to drill down to get there. Just like time zone was at the highest level of the onion, the outer layer of the onion, this is also at that outer layer of the onion. So to get there, I just put DT. Like that. Okay, I close it and I close the parentheses, and I do not like being a munchkin, so I'm going to leave the munchkin mode there. All right, so that is going to be like that, and so I close, I got to close the string too, like that. Okay, so now I should at least get that ridiculous number. Congratulations, you have connected. And then what does it say? This number I suspect to be the date and the time, but it's a big crazy number. And what is that big crazy number? Well, when you ask for time and you get this big crazy number, usually what it is it's the number of seconds since the epoch. Okay, when was the epoch? It was something like January 1st, 1970 at midnight in like universal coordinated time, like wherever that meridian is of exactly UTC, it's that, and it's the number of seconds since then. Now that's kind of frightening, but I'll show you how we should be able to go in and we should be able to kind of get something useful out of that. All right, so what I'm going to do is I printed the date time, okay, and now what I want to do is I want to, suspecting that that is the epoch time, I want to try to convert it to more like a readable time. And so now what I'm going to do is I am going to say that I'm just going to say TM is going to be equal to time, that library that we imported, dot local time. Okay, and so I want to convert something to local time. What do I want to convert to local time? That crazy number, which was weather, and then DT, okay, and then close the bracket, and then close that. Now I have TM, and now I'm just going to print TM like that. Okay, and so now do we get something that might look more like a real time? Okay, congratulations. Okay, look at this. We got an array back. Well, what do I suspect 2023 is? I suspect that that is the year. What do I suspect 8 is? 8 is probably the month. Okay, well today when I'm recording this is actually August 8th, but since it starts at year, I would assume the next one is the month, which would be August. The next one is the day, which would be 8. So I think I've just gotten the date, if I am not mistaken. And then I've got 6, which could very well be the hour. And then I've got 17, which very well could be the minute. And then what would that 4 be? Do you think that 4 could be seconds? Let's see if it changes quickly. No, it didn't change. So this is probably year. This is month. This is day. This is this is month. This is day. This is hour, and this is minute. And let's just say I am not sure what the 4 and the 1 and the 220 is. If we Googled that local time command, we could probably figure out what it is. But I have what I need, so I'm not gonna fool with it anymore. All right, so now let's see if we could print out something a little bit more interesting. So what I'm going to do is I'm going to print, and you see that this TM variable is an array. So what I'm going to print is I'm going to print, let's see, I'm going to print, and I'm going to turn this into a string. And so I'm going to take the string value of what? Of DT, okay, and then DT, no, of TM, that variable that I just created. I'm going to take the string value of TM, all right? And then what do I want? I want the 0, 1, 2, 3. I want the hour. So that would be the third element in the array, okay? And then I want to concatenate that, tack onto that a semicolon, and then I want to tack onto that str of TM, and now I want the minutes, okay? And what would that be? That would be the fourth element of the array. So this is the third element, this is the fourth element, and that should give me the time, like hour, minutes. All right, and then that's the time. And then what I would do is I would probably put, go ahead and let's put the date on there too. So I'm going to concatenate it with a little bit of a space like that. And now I'm going to concatenate that with the date. And so what I'm going to do is that would be string of TM. And then what would that be? Well, that would be 0, 1. So that would be 1 would be the month. So that would be 1. All right. And now I want to put the slash. Okay. So I'm going to concatenate with, in quotes, a slash, and then concatenate with what? String of TM. And now I want the day, which would be the number 2 element, okay? And then I am going to concatenate that with another slash, okay? And then I'm going to concatenate that with what? String of TM. And I think I see a mistake that I made here, but I'll go back and fix it. You guys probably caught it. String TM of this time, I want the year, which would be 0. Okay. And then I will close that. You see what I did wrong here? I want TM of 2 in the string value of that. And I want TM of 1 and the string value of that. So you see I put this in the wrong spot. Hopefully this is making sense. Man, this is really kind of a clown show here on this one command, but let's see. Now something doesn't match. So okay, I closed the TM, but now I've got to close the whole print. So open close plus open close. So this is not balancing out. This is not balancing out. So you guys show me where I made my mistake. I have an open parenthesis and a close parenthesis. And then I have an open parenthesis and a close. I've got an open and a close. I've got an open and a close. And I've got a plus open close. 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 And I didn't put a plus there. Okay. So did that fix it? Plus that, plus that, plus that, plus that, plus that, plus that, plus that. That sure looks right, but what is it not like in line 25? I don't have a line 25, so that must be inside the library print. Okay, so what I am going to do is, let's just see if I got that much right. So I'm going to take this much and I'm going to cut it like that, and will at least that much work? I'm just not thinking about something right. So I print TM, and I should be able to index TM. And so let's just look at TM again. This is I'm going to comment that out. Somehow I'm not thinking about TM right. So let's look at TM. Okay, so this is TM, and I should be able to index TM, and I should be able to make it a string. So I printed all of TM. And so let's just see if I just, what I'm going to do is I don't want to lose all my typing, so I'm going to come here, and I'm just going to say print TM of 3, like that. Okay, can I do something simple like TM of 3? And guys, I leave these errors in so that you can see how I debug things. Okay, so I printed TM, which is here. And then I said print TM of 3, 0, 1, 2, 3. I should have gotten a 6, but I didn't. This is, oh, there it is. Okay, there's my 6, so I can do that. So if I can do that, okay, I think one thing I see that I made a mistake here is, let me take this off. Okay, print. I should not have put that open parentheses. Now everything looks happy, right? I had an extra open parenthesis in there, and that probably drove you insane watching me do that. But now let's see what happens. Okay, so look at that, 624 on 8/8/10/23. Okay, that was a little bit painful. It was a little bit tedious, and might I say a little bit embarrassing, but we did get to the bottom of it. So now I've got, from my weather report, I have the time, okay, and I have the date. Now, what is the problem? Here in Jinja, Uganda, it is not 624, it is 924. So I am off by exactly 3 hours. Why? Because that date time is reported in UTC. So what I need to know is I need to know how to convert from UTC to Jinja time. So how would we do that? Now, you wouldn't do it for Jinja time. You would do it for wherever you are. But what I would just say is UTC time in Uganda, like that. And then I should be able to find out what the conversion is with a really simple thing. Okay, so what this says is right now it's 9:26 in Uganda, and that is UTC plus 3. So I need to take the UTC time, and I need to what? I need to add 3 to it. So where we got the UTC time, this, which was the time dot 3, that was the 6. What do I need to do? I need to add 3 to it. And I'm not just adding 3 to make it right. I'm adding 3 because I looked it up, and that is what it said to do. So now let's look and see what happens. And look at that. I now have the time and the date. Pretty good progress. All right. But what was it? What was this nonsense about a time zone and 10/800 that it reported there? I wonder if that would be like a correction factor, which instead of having to look this up, because if you ran this in a different location, you would always have to be adjusting your code. But what if I said, I wonder if that is the correction factor. So instead of adding 3, what if I added weather? Okay, weather. No, I wouldn't add it there. Okay, what I want to do is I want to add it up here to local time. So I take the weather of DT there, and what if I added the weather of time zone? Okay, like that. And then that would add this number, and then would that make things come out right without here adding the 3? You have connected. Boom, look at that, 924, and done legitimately from the data. Okay, I think that is really neat. I hope that I don't drive you guys crazy, but it's just on these data files, so many times when I'm doing things, I can never find good documentation on exactly what's what. So I like to go in and just dig into it and kind of figure it out. And hopefully you can watch me and then kind of understand how to do this in the future. All right, so that is all pretty neat. Now, I think what I want to do is I want to take all this nonsense out because I've sort of dealt with that part of it. And so where I do this, I'm going to leave the print weather, but I'm not going to print that, and I'm not going to print that. Okay, and I'm not going to print the TM now because I got what I want out of that. And now I'm just going to end up with something useful. Congratulations, you have connected. And then what I wanted was this. And then now, one of the things that I notice here, like as we start looking into all this data, one of the things that it reports back to me where we are. And that is down here. And let me see, you know what I think I'm going to do? I think I'm going to try to, give me just a second to do a little Windows management here. I think I'm just going to pull this over before I end up putting this stuff behind my head, which would indeed annoy you quite a bit. So I want to make sure that you're able to see this data as I'm going. Okay, so if you look way down here, at some level of the onion, it's telling me where I am. Okay, so where is this in the level of the onion? So I open time zone, I open that. I like to kind of look here. All right, I like to kind of look here. So that closes the whole dictionary. This one closes this dictionary. And then look at this. Inside of all this mess, I've got an array. The array closes, and then the array opens, and that's under weather. And so here, it could be, if I'm looking at this right, this is actually the outer layer of the onion. And let's see. It looks like it's giving me, and up here it gives me the country as well. So let's see if I can get here. I think maybe that this just might be name. So let's try and see. Let's try to see if that works. I'm just going to say, and I want it. I want to put it above the date and time. So I'm just going to say print what weather, the overall data structure. And then let's see if it's just under name, if I'm looking at this right. Okay, close all that out. And so now let's print. Okay, so we're going to get the whole data structure. Yeah, there it is, Jinja. And now what if I concatenated that with a comma, right? And then a space after the comma, and then I concatenate that. Now I want to come up to my country. And look, the country is not at the outer layer of the onion. The country is in a dictionary, okay? And the key word for that dictionary is sys, okay? So what I'm going to do is I am going to concatenate that with weather. And then what do I have to drill down to inside of the sys dictionary? Okay. And then close that. And then the next thing is that the index is country. Okay, so now if I go country, like that, that should drill down to that if I'm thinking about it right. So let's run this and... Okay, look at that, Jinja, Uganda. Now I'm just going to add a little greeting here at the front. Just say, welcome to, and then I will close the string and then concatenate that with the weather. So let's look at that and see what it is. Okay, welcome to Jinja, Uganda. Now let's put a little bit of a friendly greeting here and say, local time colon, and then close it and concatenate it like that. Let's try that. Okay, look at that. Welcome to Jinja, Uganda, local time 9/24/88/1023. Okay, well, we haven't gotten to the weather, but we're getting our little weather app built here, aren't we? We're getting our little weather app built. So now let's look and see some other things that are interesting. When we look inside this system, it tells us sunrise, and then it tells us sunset. That looks like pretty useful information to include in our little app. And this time we're not going to fool around with it that much because we know that this is the time from the epoch, and we saw how to do that. And we also know that we need to correct for time zone. So I think we're going to just try to do that all at once. And so I'm going to put sunrise is going to be equal to, how did we do that earlier? It was time dot local time, like that, of what? Of weather. Okay, and this time that weather is going to be under what? The dictionary system, that keyword, and then it is going to be further indexed by what? Sunrise. Okay, and so then that is going to be sunrise. Do you guys see what you have to do? You see that, you know, this is at the second layer of the onion. So I've got to index it on system, and then I have to index it on sunrise, like that. Okay. So then I also need to do, though, I need to correct for the time zone. So I already know that that is going to be weather. I'm going to add that correction, weather. This time the outside layer of the onion, time zone. Okay, like that. I close that, and then I close that. And now let's just print SR for sunrise, see if it looks good. All right, so this should be something like 6 something in the morning. Why did I not get an SR there? That's crazy. Maybe, okay, oh yeah. Now I have to index that for time. But you see what this looks like is it's saying that it was on 6:48 for the sunrise, which really that would be correct, right? And that's already corrected for the time zone. So that happened exactly like I wanted, but now I have to build something, I've got to build something interesting. So instead of printing SR, what I'm going to print is the string sunrise at, okay, space. Now what do I want to do? I want to sunrise at, and I like to use single quotes like that. Sunrise at, okay. Now I'm going to concatenate that with, we're going to have to think, so this is going to be SR, and I'm going to take the string value of it, so the string of SR, sunrise, of what index? It's going to be 0, 1, 2, 3. Okay, 3. All right, close the string, concatenate with a colon, and then concatenate with the string value of the sunrise value of the minutes, which this time will be 4. Okay, close the, and I don't want to put that. Okay, so sunrise of 4, like that. Close the string, close the print. Now let's see. This might actually be kind of interesting. Let's see if it works. Sunrise at 6:48. All right. Now we also want sunset, but we're going to be a little lazy, so we're just going to copy these 2 lines of code, and we're going to copy and we're going to paste them. And then this time, instead of SR, it's going to be SS, and SS is weather, and the system, instead of sunrise, it's going to be sunset, sunset. And then here we're going to say sunset, and then this is going to be sunset of 3 and sunset of 4. So now let's see if we're kind of making our way through this thing, aren't we? Okay, welcome to Jinju, Uganda, local time 9:36 on 8/8/2023, sunrise at 6:48. Sunset at 18. I hate military time. I hate military time. So what are we going to do here? Sunset is always going to be afternoon. And so what I'm going to do here is on the sunset, on that local time, on the hour here, I am going to subtract 12. Okay. And then that will take off the military time. And then here, I think what I will do is concatenate with a PM and maybe a space before that, and then like that. And let's see how that works. Okay, yeah, sunset at 6:56 p.m. There might be some other way to do it, but that's just the way I see to do it. I'm beginning to like this. I'm beginning to like this a lot. Okay, so now we have the sunrise, we have the sunset, and let's see, what do we want to do now? Now we ought to kind of crack in there and see if we can get some actual weather data. So if we look at this, what we can see is I've done this. I got the sunrise. I use the country. I use the sunset. I don't have to use every single piece of data. Like there's this index of base, which tells you it's from a station. I don't find that very interesting. The next index is main, and then main gives you a what? Another dictionary. And it seems like inside of main is a lot of the actual weather data. So what would we care about most? Well, what I really want is just the present temperature. Now you could put in like a day high and a day low, and you could do that by using your temp max and using your temp min. But I don't want to make it that tedious on you guys, so I'm just going to kind of hit the high spots. So what I want is that temp, okay? And so what I'm going to do here now is I'm going to say print, and I'm going to say current temp, right? Now I have in degrees Fahrenheit. Why do I have in degrees Fahrenheit? Is because I put units of imperial. If you put in units of metric, then you could get all these things in meters, meters per hour, or kilometers per hour, or temperature centigrade. Okay, but I'm doing mine for imperial units. So then knowing that the current temperature, I'll put a space, I'm going to close the quote, and then I am going to concatenate that with the string value of weather. Okay, and then how do I index it? Well, what did we see? We had to come down here, and at the outer layer of the onion, I've got to index on main. Okay, and then I've got to go ahead and drill down into what? Temp there, because temp is under main. So then I'll go temp like that. Okay, close it, and then concatenate it with a Fahrenheit. And I don't want to look up the degree thing. You guys can put the little degree symbol if you want, but I don't want to be that tedious. I want to keep moving along here. That closes this. Let's see. I got to close the string here. Okay. And then I put the F, and then that looks good. So let's see if that's going to work. Okay, current temperature, 76.21 F. Now, another thing that would be really good, I think, to get right now would be the humidity. And so this, because I'm lazy, I'm just going to take this print statement, because you see how the humidity is at the same layer of the onion as the temperature is. And so the statement should be very, very similar to this. And so what I'm going to do is, what was that? That was craziness there. Let me Control C, get rid of this, Control V, okay. And then I'll say current humidity, and that is going to be main. And instead of temp, it is going to be humidity, like that. And then this would be a percentage here for the units. All right, so now let's look. Okay, welcome to Jinja, Uganda, and current humidity. That's looking good. Okay, now a really interesting one here is also is also barometric pressure. Okay, and I think that is in that same level where we come down and we have main, and main leads to this dictionary. And then what we have is we've got kind of this strange, we've got this strange group of things related to barometric pressure. Okay, we've got this strange thing leading to barometric pressure. And what you can see is that there's several different ones. Like I can just come in, let me highlight this again. Okay, and so under main you have pressure. Okay, and that is the barometric pressure in like HPA, like a very strange unit. So I will want to convert that to atmospheres. And so under normal conditions at sea level, the barometric pressure would be 1 atmosphere. If it's more than that, then you have a high pressure system. If it's less than that, you have a low pressure system, but you're going up and up and down around, up and down around 1 atmosphere. But the thing is, you are not at sea level. Where you are is you are at ground level. And because I'm at ground level, as I go higher and higher and higher, let's say I'm at 3,000 feet here. If I'm at 3,000 feet, the barometric pressure is going to be a lot less than 1 atmosphere, not because I'm in a low pressure system, but because I'm high in altitude. But if I just want my raw barometric pressure, I would come in for ground level at 888. Okay, which is a lot less than 1,016. But that is because the pressure goes lower as you go up, just simply because the air gets thinner. So the problem is, if you wanted the real absolute actual barometric pressure, you would use this one. But the problem with that is you're going to be coming up and down, not around 1 atmosphere, but around this thing associated with you. So it's kind of hard to tell. And so I am not going to use this one. And then also, this is kind of telling you what it is if you were at sea level, which would be this. But what then is pressure? Man, I hope this isn't too confusing. Pressure is taking your actual real barometric pressure at your elevation and normalizing it as if you were at sea level, so that you can always be going around the 1 atmosphere variable. So the one that I will choose to use is this one here, pressure. Okay, and so what I am going to do is, I think I'm going to take this print statement and I am going to copy it, and then I am going to put it here, Control V, and instead of current humidity, I'm going to say current barometric pressure. Okay, and then it is going to be main, and then it is going to be pressure, and this should be around 1 atmosphere when we convert from HPA to atmosphere. And then this would be, I'm not going to put a unit yet because, well, this would be HPA would be the units. All right. Does not like that. What did I do wrong? Is it little p? Maybe it's little p. All right, let's see. Okay, little p is 1016 HPA. Okay, now what's wrong with that? HPA is kind of like a crazy thing, and it's almost like something like 100 at it's. I don't even want to try to explain. I'll show you how you can convert. I will show you how you can convert to actual atmospheres. You take this, and inside, before you convert it to a string, you multiply it by the magic number 0.00098692233, and that will convert HPA to atmospheres. And this should be a number very close to 1. And if it's more than 1, I'm in a high pressure system. If it's less than 1, I'm in a low pressure system. Okay, look at that. I am at a current barometric pressure of 1.002 atmospheres. So that means I'm almost just absolutely normal, but I'm a little bit tiny, little bit high in pressure, above 1 atmosphere. Man, I hope I didn't just completely confuse you about there's the absolute barometric pressure, there's the barometric pressure that is adjusted for your elevation, which I've done, that's the one I've used, and then I've converted it to atmospheres. Okay, so enough of that nonsense. What would be something else that would be useful? Okay, we've done, let's look here in this main dictionary. And what do we have in that main dictionary? I think we've kind of milked every useful thing out of there. What do I have now? I have visibility, which I don't really care about that much, so I'm not going to put that. And then I've got an ID, and then, you see, I don't want to index on clouds because I don't know if that's there every time, and I think there's something more interesting than that. Look at this. It also is going to give me my coordinates, my longitude, and my latitude. And then also we've used this already. There's some type of code here that I don't care about. Okay, now one that I think is interesting would be weather. And what I can get from weather is I can get like what it wants to say. Like under weather main, it's going to say clouds. Or weather main is the index, the value might be sunny, or it might be rain, or it might be thunderstorms, but the kind of one-word description of your weather followed by a little bit more of a description, like it might be thunderstorms heavy, or it might be sunny hot, or it might be clouds and then broken clouds. So that's I think that's pretty important. So now what I'm going to do is I am going to print current conditions, concatenated with plus, and this I don't need to convert to a string because it's already a string. I'm going to say weather, okay? And how do I get down into that? The first layer of the onion is weather, so I'm then going to go here like weather, like that, okay, and close that. And then inside of that, I have, what was it, main, like that, and then close that, and then close that. And it doesn't like it. What did I not balance there? I used a double instead of, okay. So now it's happy. Now what this should just do is current conditions should be clouds. Not a string. So weather main, let's look at this. So I've got weather, gives me a dictionary that comes here. So weather should give me this dictionary, and then weather main That cloud sure looks like a dictionary to me. Weather, weather. Okay. Weather does not give me a dictionary. Weather gives me an array. Okay, do you see this weather? So when I index weather, weather, believe it or not, is not pointing to a dictionary. It is pointing to an array. So I've got to index it as an array, and I could take the 0th element, and then I could go down to main. But you see, I didn't pay attention to that little one there. So now let's look. Okay, conditions, clouds. All right, now what I also want to do here is I want this description, which is the next one. So then I'm going to concatenate with a comma space, and then I am going to concatenate with this same thing, copy, and then paste, but instead of main, I want the description. All right, now let's run it, and I think this is going to work. Okay, look at that, current condition, clouds, and broken clouds. That looks good. Now, the one thing that I don't like here, do you see how under the weather, it is giving me an array, and I did the lazy man's way, and I just said, well, just take, there's only one, just take the first one. Hey, but what if it was something more that there might be in other cases, like it might be clouds, and it might be thunderstorms, or it might be clouds and rain. There might be more than one. And so what I need to do is I need to step through that array. So I'm going to say for I in range, and then how many do I want? Well, how many are there? So that would be the length of the array weather of weather, close it. So it's what I'm asking it to step through under weather. How long is it? Well, if it's 1, we'll step through 1. If it's 5, we'll step through 5. And so I want to step through the length of weather. How long is that? Okay, so then I need to close that, and then I need to close the length, and then I need to close the range, and this is going to be a for loop, and then this is going to tab over. And now instead of saying take the 0th one, I want to take the ith one. So every time it will take the ith position there and there. So let's try that. Should give me exactly the same result, but in the future, if there's more data there, it will pull it out. Current condition, boom, got it, giddy up. Okay, so now that is pretty interesting. And so the other thing that I'm just think I'll do one more. Okay, and what I'm going to do is let's go ahead and get the wind speed. Now you could do the gust and you could do the other things, but I'm just going to do the wind speed. So what I'm going to do is I'm going to print, okay, and then I'm going to print wind colon space, close that, concatenate it with again, this is a number, so I'll have to take the string value of it, of weather. Okay, and then where is that wind speed? Is it inside of weather? No, it is not. Is it inside of main? No, it is not. It's down here at the outer level of the onion, and so it's just going to go, we'll get to it directly from wind. Okay, like that. And now we've got to drill down. We've got to drill down to what? Speed. Drill down to speed like that. Okay, now we are going to close speed. We're going to close We're going to close the string. Okay, and now I'm going to concatenate with that the space miles per hour because I am in imperial. All right, I think that should give me the wind speed. Let's see. Okay, 4.5 miles per hour. Okay, now what you could go in is you guys could go in and put more things in, right? I haven't done every single one of those things, but I'm showing you enough that you can see how to do it. Now, I don't want any more of this printing out of the whole data structure because if someone's actually using that, that is going to be confusing. So we're going to come in and we're going to print this. And we are going to look for our weather report. Congratulations, you have connected. Welcome to Jinja, Uganda, local time 9:59 on 8/8/2023. Sunrise at 6:48, sunset at 6:56. Current temperature 76, current humidity 56, barometric pressure a tad skosh on the high side, conditions clouds, broken clouds, and wind. Wow, we have ourselves a remote sensorless weather station based on the Raspberry Pi Pico W. Okay, how cool is that? All right, now what I've focused on today on this project is getting you to get the data and get everything parsed apart. So now you have all the data, but really you want to make it more interesting because I could just get the weather by clicking on my PC here and getting a weather report from some little widget like that. But really what you want is you want something where you have like a remote weather little widget, a little object. And so what your homework assignment is now that you have all the data, make something more interesting. So like one thing is we want to go remotely. So we're going to run on the battery and not have it connected to anything, so you could put this anywhere you wanted. And then you want to use your little OLED display link down below, or you can use the LCD display from the kit, and I've already shown you how to hook the LCD up, or you can use your OLED. And then I think it would be interesting to put some other little devices, like could you put some interesting like visual stimulus coming out of an RGB LED, or maybe you would want to figure out one of the other components in the kit or something, but make something that then becomes a little put anywhere you want weather station that will give you the interesting information. So that will be your homework assignment for next week. Guys, I hope you are having as much fun taking these lessons as I am making them. If you enjoyed the video, give us a thumbs up. Also helps us with the old YouTube juice if you will leave a comment down below. Make sure that you post your homework assignments. Make sure that you post your homework assignments as you get them done. Always link back to this video, and then down in the comments below, link back to your homework assignments. As always, I want to give a shout out to you guys who are helping me out over at Patreon. I'm not being treated with much love these days from YouTube, and so you guys that are standing with me on Patreon are really helping me keep these lessons coming. Appreciate it. Thank you guys. And then also, if you haven't subscribed to the channel already, make sure you do. When you do, ring that bell so you'll get notifications when future lessons drop. And as always, share this video with other people because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.